Hey everybody, and welcome back to Front-End Expert. In this video, we will be discussing classes and the inheritance model of JavaScript known as prototypal inheritance. The core idea of prototypal inheritance is that objects are able to inherit from other instantiated objects. We call the object that is inherited from the prototype. When a property doesn't exist on an object, JavaScript looks at the prototype object for the property. And if that object doesn't include the property, it looks at its prototype and so on, creating what we call the prototype chain, which ends when an object doesn't have a prototype, so its prototype would be set to null. This differs from classical inheritance, which you might be familiar with from other languages such as Java. In this model, you would create blueprint classes for defining how an object is created, but those classes aren't objects themselves. So again, the key difference is that in JavaScript, objects inherit from other instantiated objects rather than these blueprint-style classes. Okay, so let's see what this looks like in practice. We can say const person and set this equal to an object literal, and give the person an isHuman property. We can set this to be true, then we can add the semicolon at the end of this declaration. So now we have a person, and of course we could log out the person, so I could say console.log of person, and you can see, as you would expect, we log out this object. And if we want to create another object that inherits from the person, there are a few ways to do it. So first, let's create a child. So we can say const child, and what I'm going to do is I'm going to use object.create, so the method to create an object, and this can actually take in another object as a parameter, and it will set that object to be the prototype. So I'll set the prototype to be the person object, and now child is going to inherit from person. So we can console.log person, and we can also console.log out the child. And you'll see our child is just an empty object because there's nothing directly on this object. However, if I log out child.isHuman, it will be true. The reason for this is that isHuman didn't exist on the child object, but it exists on the prototype, on the person object, so it looks at this inherited property, and that's where it gets the isHuman value from. Now, when we use this object.create syntax, what it's actually doing is it's setting a property like child, and then you could imagine we would have a property with this name, and it is prototype. And this property is what it sets equal to person, but this property is not something we can manually edit. So we don't have the ability to edit this. As you can see, this isn't even valid syntax. This would throw an error if I tried to run it, but this is what it actually does. However, we can use an alias for this. So we have __ proto, and this allows us to manually get and set the prototype of an object. So for example, if instead of using object.create, we simply had an empty object, this would end up working the same way because we set the prototype to be person. However, if I comment this out and run the code again, you will see we get undefined because now we have no isHuman property on the child, and its prototype has not been set, so it is going to default to just the object prototype, which does not have an isHuman property. That said, using this __ proto is considered to be a bad practice. We usually don't want to use this in production anymore. It is becoming deprecated. That said, you will still see it a lot. Browsers all still support it for the most part, and they will support it for a long time. And this is how we did things initially. But there are better ways to do this now, such as what we did before, where we set the object.create method to have the person as a parameter. And of course, we can still edit the object. So for example, I could say child.maxAge and set this equal to 18. And then if we log out person.maxAge, it will be undefined. However, child.maxAge will be 18. So the prototype chain is only in one direction. Child is inheriting from person, but person does not inherit from child. Next, there are a few alternatives to this syntax here, so I will comment this out, and for example, we can say const child, and we will set this equal to object.assign. So remember, assign takes in a target and a source object, and it copies all of the properties from the source to the target. So what we will do is for the target, I will say object.create, and we will create a person. And then for the source, I will add in any properties we want, such as max age. So we have the max age of 18, and what this is going to do is it first creates a person. So it creates an object with the prototype to person. Then we assign all of the values from this second object. So we assign max age of 18 to the object that we are creating here. And thus child becomes the same object that we had up here. And I can run this code and you'll see we still get 18 for the child max age. And you can see we could also still do child.isHuman, and this would be true. Next, what we could do is instead of this, we could simply say child equals, and then the object literal of max age, set this to 18, and then we can use a function. So I can say object.setPrototype of, and this takes in the object we want to set the prototype of. So for example, child, and then what we want to be the prototype. So what we want to inherit from, and I will say person. And now when I run this, we get the same output. I would, however, discourage using setPrototype of when you can though. The reason being that browsers are not very well optimized for changing the prototype of an object. It does work, but if we had to do this a lot of times, such as in a very long loop, it would actually cause the browser to slow down a lot. This is a very slow operation. So usually we want to set the prototype on an object when we create it and then never change it again. And then again, like I showed a moment ago, we can use the _proto. So I could get rid of this and we can add a comma here and then do the proto like this. And this is simply a getter and setter property that objects all have that sets the internal prototype to whatever we put here. So this will work the same way. But again, this is discouraged now. It's sort of an older syntax that we don't tend to use quite as much anymore. Okay, so now let's get rid of this, come back to this code, and then finally I want to show one last option, and that is that we can add another parameter to object.create, and this parameter is going to be an object. And the keys are going to be the keys of the object that we want to have, such as max age, but max age needs to be set to another object. And this is where this can get a little bit complicated, so I usually recommend not using this unless you need to, because you'll need to look up a bunch of different properties or have them memorized. But this will take a value first of all. And for example, we can set the value to be 18, but then there are some other properties we need to set. First of all, we have a writable property, and writable says, can this value be changed or not? So I will set this to be true. Then we have configurable. And what configurable does is it says, can we change any of the values on this object? Usually we want that to be true as well. And then we have enumerable. And enumerable says, does this property need to show up when we are iterating through the object? And usually we want that to be true as well. And then we could get rid of this child.maxAge, and this will work the same way. However, like I said, this is a lot of code for the same thing. So most of the time I would recommend not going with this version, and I would either use the object assign functionality, or I would simply set the properties after creating the object like we are doing here. Okay, so now what I want to do is I want to create one more object. So I will call this object, let's give it a name. So I'll call this one John, and we will set John equal to object.create of a child. And we can give John a property, maybe John.name, and set John's name to be John. Okay, so now we could console.log out John, and I will get rid of this code below just so we can see what we're doing a little bit better. And you can see we print out this object with just the name of John. However, if I console.log out John and then we could get the prototype, you will see we end up logging out the child object, so the object with max age. And if we did john.proto, we will log out the person object because the prototype of the prototype was person. So what this means is that John has access to all of the properties of person and of child. So for example, we could say John.isHuman, this would be true. We could also say John.maxAge, this would be 18. And we can say John.name, and this is John. We can also use this function object.getPrototypeOf, and this is sort of the replacement of what I just showed with the __ proto for getting it. So we can use object.getPrototypeOf John, and you can see we end up with the child object. And if we wanted, we could sort of nest calls to this in the same way that we did .proto, but it's a little bit easier to look at with that older syntax, but this is the recommended way to do this now. Okay, so one more component to this that I want to show is that if any of these objects change, it will change the properties on all of the prototypes as well. So for example, if I did child.maxAge and change this to be 19, now if I do john.maxAge, and we can console log this out as well, so we can say console.log john.maxAge, you will see we get 19. However, if we did this before we change the property on child, we get 18. So these are live objects. They are references to the actual object. It's not copying properties over or anything like that. The prototype property is literally a reference to another object. Okay, so let's get rid of this code. And now what I want to show is something a little bit unique about JavaScript, and that's that almost everything that's not a primitive is an object. For example, what I want to do is get the prototype of a function. So let's say const func proto, and we can set this equal to object.getPrototypeOf. Let's just pass in an empty function. And now the interesting point here is let's do console.log, and we can say object.getOwnPropertyNames. So what this does is it gets all of the properties that are own properties on an object, and we pass in the func proto. And since func proto is the prototype of this function, it is the actual function object itself. And now if I log this out, you can see we get an array of all of the different properties that are on the function prototype. For example, we have toString, we have bind, we have name, color, apply, call, the length, and we have the arguments. And we can do the same thing for an array. So let's say array proto and pass in the array to get prototype of. And if we log out array proto, you will see we end up getting a huge list of all of the properties on the array prototype. So for example, we have the concat function, we have the find function, pop, shift, sort, etc. So the key point here is that arrays and functions are simply objects. They are objects with their prototype set to the either object, so the object with the name object, or the array object, which has all of these properties that we can use on it. Okay, now what I want to do is let's remove this code and let's look at function constructors again. So we saw these in a previous crash course video, but I want to take a little bit of a deeper dive in what these are doing. So let's say function person, and a person takes in a name, and then we can say this.name equals name. Okay, so this is a simple person constructor function. So we could do something like const Connor equals new person and give myself a name of Connor. And then we could console.log out Connor, and you'll see we get this person with the name of Connor. Okay, so what does the new keyword actually do? Well, we know that it calls this function and it assigns this keyword, so this keyword, to a new object. But how does that end up working? Well, the way it works is that every function has a function name, so the actual function, the object of the function, dot prototype. And this is different from the __ proto. This is a different concept that just has the same name. This is a standard property on the function object. And what this is it's an object itself. And this object is going to be a bit of a blueprint for how the new keyword is going to work. So the first thing we always need here is a constructor. And the constructor by default is set equal to the person function. So the function that is sort of this, in this context, the function that the prototype is on. And then any other properties that we add here will be added to any instances of a person. So for example, is human, and we can set this equal to true. So now we can run this code again, and you can see we still have person with the name of Connor, but Connor also has is human, and this will be true. The reason being that Connor's prototype is this object. So if I did Connor dot underscore underscore proto and log this out, you can see we actually get this object here. Same thing if we did object dot get prototype of Connor, we would get that same object. So the prototype becomes this object. When we use the new keyword, it sets the prototype of the object it creates equal to the object that is the function dot prototype. And then it calls this constructor. So if I did something else in this constructor, for example, let's just console.log here, you'll see that now when I run this code, we console.log here because this gets called when it starts creating the new person. And what this essentially means is that the properties that we set here inside of the actual constructor function are going to essentially be instance properties. This .name is specific to a single person. So for example, if I copy this code and we create a Clement and make a new person that is Clement, and now let's console.log Connor, and we can also console.log Clement. These have different names, right? They have the names that we passed into the constructor, but they have the same prototype. So if I did object.get prototype of Connor and check the equality to object.get prototype of Clement, these are going to be the same. It is true. So the Connor object and the Clement object share the same prototype object. They are not copies of the object, they're the exact same one. For example, if I did something like person.prototype.test equals, we set this to be test, then both Clement and Connor will be able to access the .test property. Similarly, if I did Connor dot, and let's just get the proto like this, dot test and set this equal to test, this is still going to work. So Clement.test is getting the test property off of the same proto object as Connor. So these objects share the same prototype. They are not copies of the prototype. They are the exact same object. What this also means is that we can call the constructor function, which can actually be somewhat useful. So for example, I could say const Clement and set Clement equal to Connor.constructor and then pass in Clement. And then we will need to add a new keyword here, and I will capitalize the C in Clement. And this will be the same thing as this line of code here. So we can run this, everything's working the same way. And we can also just console.log out Clement, and you can see we get a person with the name of Clement. And the reason that this works is that the prototype of Connor is this object. And this object has the constructor, which is set equal to person. So Connor.constructor is literally equivalent to the name of person. They are the exact same function. And this idea of sharing prototypes can also work pretty well with functions. So for example, let's get rid of this code for a moment, and we could say something like person.prototype.speak. And let's set this equal to a function. And what we're going to do in this function is say console.log, hello, this is, and we can concatenate this with this .name. And now we could do Connor.speak as well as Clement.speak. And when we run this code, we get hello, this is Connor, and hello, this is Clement. So this keyword inside of the prototype is still going to be a reference to the instance of the object, which gives it access to the name property, which is specific to the individual objects. And we, of course, also have access to the prototype because of the fact that this is set equal to the object, which has access to that prototype. So for example, you could also do console.log of this.isHuman, and you'll see we log out true both times because we have is human set to true on the person prototype. Okay, now let's remove a bit of this code to make some room. And what I want to show is a operator known as instance of. So let's do console.log. And what instance of does is it takes on the left-hand side of the operator a name of an object or an object. So we can say Connor, and then we can say instance of, and then we take in the function that we are checking if this is an instance of. So the constructor, for example, person. And now if I run this code, you can see this is true because Connor was an instance of the person. Essentially what this is doing is saying is somewhere in the Connor prototype chain, the person.prototype object. And we could do the exact same thing for Clement if we wanted. So we could say, is Clement an instance of person? And we would get true for that as well. We could also set the instance of to be something higher in the prototype chain. So all objects eventually end up inheriting from the object. So we can say, is Connor an instance of an object? And the answer of this is true. But for example, if I said an array, this would be false because Connor is not an array. Nowhere in the prototype chain is the array. However, if I do object.setPrototypeOf and pass in the Connor object and set its prototype to be the array.prototype property, now Connor is an instance of an array, and you will see we end up getting true. But we usually don't want to be setting prototypes like this. This is simply for an example. Of course, setting Connor's prototype to be array will lead to all kinds of issues because almost none of the array functions are going to work on this object. However, there are some interesting use cases for setting properties on prototypes like this, particularly like how we set the speak function. So I'm going to get rid of this code. And what if we had an array, but we were using some super old browser that for some reason didn't have access to the push function. So the push function is actually array.prototype.push. But what if this function didn't exist? Well, we could just define it. So we could say, set this equal to a function, and it takes in a value. And what does the array push function do? Well, it takes the array, which would be this, and it sets the property at this.length, and it sets it equal to the value. And this isn't the exact implementation of a push function, but it's pretty close. It's close enough. So now we could say const array equals, and let's do 1, 2, 3. And then let's say array.push 4. And then finally we could console.log out our array, and you'll see we get 1, 2, 3, 4. But what's interesting is that when we call array.push, it's actually going to use this function that we have defined here, because we have added the push function to the array prototype. We could even rename this, so I could say array.prototype.myPush, and now we could use myPush here. And now what this is going to do is it's going to call the function that we wrote rather than calling the original one on the array prototype. And this concept is known as a polyfill. So there are tons of libraries out there for polyfills that simply have a bunch of functions like this that define functions that a browser might not have. And you'll see oftentimes these are wrapped in an if check. We would say something like if array.prototype.push is undefined. So if there is no array prototype push in this browser, then what we would do is define our own, and we would say push. So this would be a very basic polyfill for the push function. It doesn't do everything that the normal push function does, but it should get the idea across of what a polyfill is and why this is useful in the case that we were using some modern function that new browsers have, but older ones might not. Okay, so now let's remove this code. And what I want to do is shift over a little bit and start talking about the modern class syntax. So for example, I could say class person, and we can set a class simply like this. So this defines a new class. The class can have a constructor function. So for example, this could take in a name like we had before and set this.name equals to name. And then we can add any functions we want on the class. So any methods we want to add, such as the speak method. So we can say speak and console.log, hello, this is, and this.name. Now, this is roughly equivalent to the code we had before using the prototype chain, classes are mostly syntactic sugar, meaning that they are mostly just a new syntax for the same thing. However, that's not entirely the case. There are some very slight differences internally with how the engine is going to handle classes. That said, for the actual use case of a class, they will work the exact same way. So now what I'm going to do is create a person. So we can say const Connor equals new person, the same way as using a standard function constructor. And we can pass in a name of Connor. And now we could do Connor.speak, and you will see we end up logging out, hello, this is Connor. And we can also add fields to a class. So for example, I could say is human, and I will set this equal to true. And now we can do console.log Connor.isHuman. Okay, so that gives us true. And let's create one more person once again. So I will create our Clement object, and we can say Clement. And we can also do the same log. So we can say Clement.isHuman, and you can see they are both true. But what would happen if I said Connor.isHuman equals false? And then we log both of these out. So let's move this log after the isHuman change. And you will see we get false for Connor.isHuman, but we get true for Clement.isHuman. These properties we set here are instance properties. They're properties of a single instance of the class. We can also define getter and setter functions. So I could do get, and let's do name, and this could do return this dot name. And then we could also say set name, and this would say this dot name equals name. And this isn't super useful for this use case here. Obviously, this is the same thing as just using the name property, but there are times when this can be useful if either you want to hide a little bit of the logic of what get and set are actually doing, if there's some calculation there, or if you need any other side effects or anything like that. This syntax can be useful, but we don't always end up using it. A lot of the time, you won't see these getter and setter functions. You also sometimes might see them as actual properties. So sometimes you'll see just like get name, and then we would call person.getName rather than just using it as a standard property. Okay, but for now, I will remove these getter and setter functions. And next, we can also add static properties. So for example, I can set isHuman to be static. And what this means is it is a property of the person itself, the person class. It is not a property of instances. So let's remove this Connor.isHuman, and you can see both Connor and Clement.isHuman is undefined. But what we can do is we can say console.log person.isHuman, and person.isHuman will be true. So isHuman is static in that it is a property of the person class, not of the instances of the person. And same thing for these functions. So I could do static greet, and we can set this to be a function, and let's do console.log hello. And now the greet function is part of the person class. So I can say person.greet and run this function, and we get hello. But if I tried Connor.greet, for example, I would end up getting an error that this is not a function. So Connor.greet is undefined, and I tried to call it as a function, so that threw an error. And just like we saw with the manual prototype functions, we can also use some inheritance with classes. So I will remove this code, and let's remove some of this as well to make some more space. And then let's come down here and create another class. So we can do class child, and this one we will say the child extends the person. So now the child is going to be an instance of a person, and inside of the child, we can define its constructor. So maybe it takes a name as well, and then it also has an age. And what we can do here is we can say super, and then pass in the name. So this is going to call the constructor of the class we are inheriting from. And then we could also say this.age equals age. And then if we wanted, we could define some more functions here, but for now, let's simply create a child. So we can say const child equals a new child, and we can give this child a name. We can call them John and make them 10 years old. And now we could say something like child.speak. This will say, hello, this is John, because our child is an instance of a person, so it called the speak function from the child prototype. And to show this, we can do console.log child instance of person. And this will be true because a child is an instance of the person class. And again, instance of takes a function on the right-hand side, and person is actually a function under the hood. So when we create a class, it is simply creating a function for us. We can show this by saying person instance of function, and this will be true. So person is an instance of the function object. And finally, with the child, we can get its properties. So I could do child.age, for example, and this would log out 10. But what if we wanted to hide this? What if we wanted a private age? We wanted the age to be a private variable. The way we can do this is we add the age as an instance property, but we prefix it with the pound sign, so the hashtag, and then we can say age, and I won't initialize it here. And then instead of this dot age, we can do this dot and the hashtag or pound sign age. So now you can see we get undefined down here. And if we change this to be child dot pound sign age, we will get an error because we are trying to access a private field. So this field age is only accessible by functions inside of this class. So it can only be accessible inside of the class. It is not accessible outside of it. And this is also true of classes that inherit from this class. So if, for example, I did class grandchild, and in this grandchild class, we will extend the child class. And all I'm going to do with the grandchild class is simply say get age, and we will console.log this dot and the age property. And this is actually not going to work. So I will just comment out the code down here, and this error will happen in the declaration of the class. So we don't even need to try to instantiate a grandchild before we get this error that the private field age is not going to be accessible here. All that said, one thing to know about private fields as well as static fields is that they aren't fully supported by every browser. So it is something to be aware of, but for the most part, we are safe to use them with modern code. So with that, that's going to be the end of this video on classes. I hope you enjoyed it. I hope you learned something new, and I'll see you in the next one.